Hello everyone. So let us continue with the solution to the same definition that I showed in the previous video. That is to read a number and we expect the user to enter an integer number, though it may not be possible because on the internet anybody can enter any input. So we are making a provision of reading the value and checking whether it is a number in the first place. And the second thing we are doing is we are even confirming that the number is an integer number. Now, the solution that I showed you in the earlier one was based on string manipulation. Now, in this one, I'll show you the solution using numbers. So basically, if you have a number like 123, now as a number, what you do is you extract the last two digit and then you reduce the original number by 1. So that is divide by 10, which I have used in many of the earlier videos. Now, again, you extract the last digit. Now, before you add the next extracted digit, you shift this digit by 10. So you multiply this value by 10 and then you add the last extracted digit to make it 32 and reduce the original number by 1. Okay, so then you are left with 1. So again, before you extract this and add it to this, you multiply this number by 10 and then the extracted digit may be added to give you the reverse number. And then again, you reduce the number by 10, dividing it by 10 basically. So you get the value 0 and that is where you will stop. So finally, what you get is the reverse of the number. Right, so this is the logic that I'm going to apply, and for this I would need one more variable, say n. For now, let me just go ahead and say if at all I need it, I would use the variable. So while the value of p is greater than 0, what I'm going to do is I'm going to extract one digit and then reduce it and all those things. So finally what I'm going to print is the new number n. Now, every time when I'm extracting one digit, I would need to store it somewhere. So let's say I'm going to use the remainder. So let us start with the logic. First, we extract the last digit. So remainder is equal to the number modulo 10. So whatever is the last digit would be stored in remainder. Now, initially, we're going to start with n equals 0. Okay, so next what we do is n equals n multiplied by 10. So it shifts the digits by tens and then you add the value of remainder. So I've added the last digit to the new number which will be there in n. Initially because n is 0, 0 into 10 is 0 plus the first remainder you've extracted. So it's whatever number you've extracted. Then the next time, whatever that previous remainder that was added is multiplied by 10 and the new remainder is added. So hopefully that should work. And then what we are going to do is we're going to use the math.floor because when you divide a number by 10, you get the fractional part. So we want to avoid that fractional part. And that's it. And that should be the logic. And let us see if it works. So when you enter a number like 123, you get 321. So basically I'm looking for any number. Okay, so that's the this thing. Because there's a leading 0. Actually, leading 0 has no meaning. So if you look at the number in a different light, it actually is this number, and that's what is the reverse of the number. If you are looking for that 0 also getting reversed, then you should be using one additional step that you can think of and add into your logic. So if you enter a number with a fractional part, it's going to throw an error, just as in with the previous one, because it is not an integer. It goes to the else part and says you enter only integers, and then uh, it would say wrong input because the very first thing that is verified is you convert it into a number and the conversion fails. So it shows you the message that it is wrong input. So go ahead and try this and take a dry run of this. Basically, it's a very simple logic, very powerful logic actually. So I'll catch you in the next video with a new definition.